So I'm here to talk today about building soil fertility on my pasture, and yeah, I think it's ideal kind of across the field crop realm when it comes to soil fertility, and I've got some pretty strong opinions that there's a lot of things that we can do when it comes to soil fertility, and some things that maybe need a bit of assistance to do, and I'm hoping to kind of give a bit of my perspective here today on pastures and some of the easy ways that we can build that fertility and kind of why and how that matters. So first question that I think really comes down to is, should I care about soil fertility on my pasture? And really what I mean by that is, will I see a payback from fertilization? And really, if we answer this question and the answer is, should I care about it? If it's no, then I can give you back an hour of your time. But I think you can tell that we're maybe not going to be heading down that direction and really looking at what that payback is. So I'm going to look at a recent article that was published from a study that was funded by University of Guelph's Food from Thought program. And so what this study was looking at is kind of a global study across 6 different continents, 61 different sites, for some of those sites up to 15 years each. So a vast, wide-reaching plot looking at grasslands and kind of unfertilized pastures, measuring to see how they respond to fertilization. Really, the whole purpose of this study is the authors were trying to look at if they could figure out some kind of a model of where and when pastures respond to fertilization. The attempt was basically, we can pick out the areas that are related to things like dryness, how arid they are, the background fertility, really see how that plays into it, and see how it responds to fertilization. So these are the sites across the globe, and kind of the surprising thing, the colors here all represent the response to fertilization. So the deeper the blue color is, the more that site responded to fertilization. The redder that site is, the less that specific site responded to fertilization. And so you can see, the different colors kind of across the globe, that there's not really any rhyme or reason to any kind of geographic patterns. And so it's kind of an interesting mixed bag that we've got here when it comes to this response to fertilization. And so what this really means is the study results showed that fertilizer across the board on these 1,518 site years, on average, increased the biomass of that pasture by 43%. And so, that's great. We see an average increase, but there was no response in about a quarter of those different sites. And in most of those sites, 57 of the 61, at least one plot in 1 year had no response. 4 sites responded every year in all their plots, but all sites responded to fertilization at least once. So really, it's telling me that from this study that it's hard to predict exactly when and where we are or aren't going to see response. The best that we can do is kind of take a pretty good stab at it. And, one fertilizer program is not really going to fit every single pasture across, in this case globally, but even across the province here in Ontario. It's really a site-specific response that this study was showing. And so what they looked at is that the response was limited by low species richness, so more like single species or 1 or 2 different types of grasses. Higher pH and higher soil test phosphorus affected how that response was limited. So in the ideal situation, your site is supportive enough. It's got that background fertility enough that it's not going to see a response. But in most of the cases, like I showed, the sites responded to fertilization at least once. So that tells me that they're limiting in some kind of nutrient. And what this study showed is that, oftentimes it's something like pH or soil test phosphorus that may be limiting that especially. And so what this plot's kind of discussion really focused around is site-based fertilization being recommended. So looking at a single pasture specifically, looking at the fertilization practices within that single pasture that can be used to reduce nutrient losses from over-fertilization, but also increase the yield of that pasture and increase the profit. So if you're not making money by fertilizing that, really there's no point to it. And either taking that as hay or putting it through an animal and increasing the output of that pasture area, it all boils down to that increased profitability. And that's really where this study showed that having a specific response to that site is so important. And I'll dive a little bit deeper into this a little bit later and what that really shows in Ontario here. But when it comes to site-specific management, really the number one step is soil sampling. And so this is something that we attempt to do on a wide basis in most of our row crops. To me, we're still not doing enough of it. There's a lot of fields that would really benefit from identifying limiting factors that are going on within that field. But this is absolutely the best way to figure out what's going on within your field or your pasture as far as nutrients, and really the best way to get a response to increase that yield and profitability. So soil sampling is pretty basically is determining the nutrient fertility and lime requirements. So looking at what that soil is maybe high in, what it's lacking, and really trying to figure out where we can best place our fertility program. Can also use it to diagnose problem areas. So if you've got an area within that pasture that is highly productive and areas that are very poor productive areas, you can take samples within each of those to figure out maybe what the differences are, what's going on that may be limiting some of that fertility. And then simply monitoring that soil fertility level over a number of seasons. So it's something that a pasture, and we'll touch on this a bit later too, but it's a relatively slow drawdown versus some of our row crops that may be pulling a lot of that soil fertility out and not really having a way to place it back. So if we look at how fertility levels change over time, so we know that we can draw down that soil fertility. We know in some cases it's relatively quick, in some cases it's slow, but there's some natural things such as soil organic matter breaking down. If we're not replacing that on an annual basis, we'll eventually deplete that. Changes in soil pH, which may come through things like precipitation, soil erosion. If we're looking, within that soil profile, we've got layers of different pH, and so that soil pH can really change how available that fertility is. And then the addition or removal of nutrients is a big factor. And that comes into things like fertilizer, but also manure. And as we look at removal factors, so if we're taking that pasture for a crop of hay, we'd be physically moving that crop nutrient off the field. And even when it comes to using that pasture to feed, we are still drawing down or removing some of that nutrient from that area. So I've got here a look at two different scenarios, different management systems, and just the nutrients that may be actually pulled out of this field. So looking at grass legume hay, if we were to pull 2 tons an acre as a yield off of that pasture, we're going to be removing somewhere around 80 pounds of nitrogen, 22 pounds of phosphorus, and 90 pounds of potassium. So, with those numbers, if you're not replacing that fertility, we could be drawing down that soil test relatively quickly. When it comes to grazing beef cow-calf pair, obviously we've got a little bit different utilization where we're replacing a lot of that nutrient that we are pulling out, but we are still removing some of that nutrient from the soil. So when we look at nitrogen, if we're stocking at a half pair per acre per year, we're removing somewhere around 5 pounds per acre of nitrogen. We're actually taking more off the field, but through urine and manure, that nitrogen is returning, but about a quarter to half of that can be lost due to volatilization. So that nitrogen, it's not something that gets recycled in a full rate back to the field, but is something that we can return through just the basic anatomy of the animal. When it comes to phosphorus and potassium, it's really relatively small amounts, especially of potassium. Most of that nutrient from both of those goes through the animal and out the back end. But roughly 10 to 30% of that ingestion of phosphorus and potassium can be removed from the field in terms of whatever it is that animal's producing, whether it's meat or milk. And so again, we do see a very slow removal rate, and that nutrient, once it's gone off the field, over time, it will draw down that soil test. So the thing about it is a very slow drawdown of phosphorus and potassium on pastures. It's something that in general we're a lot more worried about the replacement factor when it comes to row crops. But given enough time, it absolutely can go from a moderate testing piece of soil to a low testing soil test, just based on not replenishing that nutrient in some way. So soil sampling, like I mentioned, it's really the best way to figure out what nutrients are in the soil, what ways we'll be able to respond to that nutrient. But then also looking at that span over time, how those nutrients are either being drawn down or built up. So when row crops, we generally say every 3 to 4 years, try to fit with the rotation as best you can. Pastures, I'm a little bit more lenient on just because we've got like I said, a bit more time frame that we're having a slow drawdown on. So 5 years is enough as long as it's kind of a regular occurrence. More to keep a check on what you are doing with that fertility to see whether it's working or not. And especially when it comes to things like soil pH, it's absolutely critical for growth of a lot of our pasture species to keep on top of that. And so I think that 5 years, even though we're having a slow drawdown, there's some naturally occurring things that go on in the soil that we still want to keep an eye on how it's progressing. The key one, soil sampling, we've got to use the proper equipment. So there's a lot of ways that you can take a soil sample that are completely wrong. And really, once you do that, there's not much point in actually doing it. So using stainless steel equipment or plastic as much as possible. Avoid any galvanized steel. That the issue is that when you're using galvanized metals in particular, the zinc from that can actually leach out and affect a lot of the nutrient analysis. And so we want to make sure that we've got the proper equipment being used when it comes to sampling. And probably one of the most important things that often gets overlooked is labeling the box or the bag when you're putting it on. Make sure it matches what you're sending in, because it's very frustrating to take 5 or 10 different samples throughout the farm and come back later and you've got no idea what actually went where. Where to soil sample is also important. So whenever we're soil sampling, we want a 6-inch or 15-centimeter depth. The reason for that is that's the majority of where the plant roots are. There are some that go deeper, but that's where the majority of the nutrients are as well. And so we want that nutrient-rich zone where the majority of the roots are, the majority of the nutrients are, to really get a good analysis of what's going on. That's also where all of our lab tests are calibrated. So if we pull a 2-inch sample, it's going to show we're at much higher soil test levels than we are at 6. Same if we were to dig down to 10 inches or 12 inches, we're going to find that that subsoil, it's got a lot less of that nutrient and it's going to test much lower. So keeping that right depth is very important. We also want to make sure that when we're sampling, we're trying to get a good representation of that area. So we want a minimum of 20 cores per sample, kind of taken throughout the area where you're sampling. And ideally, kind of a zigzag pattern or, trying to hit as much of that area as possible while still avoiding some of the hot spots, manure piles, if we've got feeders. We want to avoid bringing them in with the rest of that composite sample because that can throw off kind of that average nutrient value that we're looking at. It is a good idea to sample those areas separately. So maybe where we've got that old barnyard or where we've got that feed area, it'd be a good idea to sample those separately just to see what's going on there as well. But we want to try and keep it representative of that area as much as possible. We also want to make sure that we're sending it to an accredited lab. And I've got a site here, but if you look up OMAFA accredited soil labs, it will give you a list of all our labs that are accredited. And that's important because that makes sure that the tests that those labs are using will actually match the recommendations for that particular soil. So when it comes to soil sampling, I kind of touched on it briefly here, but in a lot of cases that pasture may not have uniform distribution of those nutrients. A lot of cases, beef cattle especially, they're moving around. They're looking for areas with water, shade, feeding areas, higher ground, and the areas they spend more time in likely to have a higher nutrient load just because of their urine and feces. So it's not deposited uniformly across that pasture. And so in a lot of cases, we may have areas with high soil test phosphorus and potassium and areas of low testing soils at the same time. One thing that can be used to reduce some of this imbalance is rotational grazing. So just keeping those animals confined into a smaller area leads to more uniform deposition of those nutrients naturally. But it's kind of important, whatever system you're using, that you can kind of be aware of that and look at how that may affect the soil sampling. And so because of that, we may need to look at our pastures a little bit differently. Instead of, taking it as one singular area, it might make more sense to break it up into, 2 or 3 different zones, depending on how large it is. You can get absolutely much finer resolution than that. But really, I think it's important that we look at areas where we've maybe got a higher nutrient load and areas where we've got a lower nutrient load. And it can be really advantageous to separate those out because that fertility requirement may be very different within those areas. And so we can often reduce the fertilizer requirements in those high testing areas and better spend that fertility investment elsewhere. So what it all comes down to is something that looks like this. And this is just an example. There's a lot of different ways that the soil test report can look at. Every lab's got a little bit different format. But in all cases, what we're looking at are a few different things. And the ones that the different analyses that I have shaded here are the ones that are OMAFA accredited soil tests. And really, these are the ones that we've identified that our crops can respond to and will respond to. And we've got a pretty good idea of what the likelihood of that response is and recommendations in order to apply fertilizer or manure to really see that response. So when it comes to a soil test, there's a few things that catch my eye right away, and what we're going to talk about tonight here are kind of the a couple of the background things that we look at on a soil test, and then the three main factors that I think when we're talking about building soil fertility on a pasture that we need to look at first. So if we look at our background, organic matter and CEC are kind of the two analyses that kind of give us a bit better picture of what we're looking at. Kind of give us some background information about maybe what that piece of soil is that we're testing, and we can kind of make some inferences from that. After that background info, the most important part of what we're trying to do here, building fertility, is the pH and the buffer pH. And then it really comes down to our phosphorus and potassium. There's a lot of different things that we can look at here. Magnesium is a very important one. Zinc and manganese are very important for a lot of our crops. Boron is one that we can see response to. But really what it comes down to is if you don't have your phosphorus and potassium in line where you want it, then it really doesn't matter what you do when it comes to some of our secondary nutrients or our micronutrients. So really the top three things that I'm going to touch on here are just what we showed here. So like I mentioned, some of the background info that's kind of good to know, gives us a good idea of what we're looking at. Organic matter is really one of the biggest indications of how maybe how much of a potential that soil has. So pastures often quite high, and the chart here that we're looking at different soil types and organic matter percentages. It's really in most cases pastures are well off the charts, very good. Organic matter is basically a reservoir of soil nutrients. It gives the soil ability to hold water, release water, hold those nutrients, cycle those nutrients. And so it's something that's very important to have, and high levels of organic matter are kind of a really good thing when it comes to soil health. Cation exchange capacity is a kind of another function of the soil. It's related to organic matter, but also the clay particles within the soil. And it kind of gives an indication of a soil's ability to hold on to nutrients or also potentially leach those nutrients. And so I'm not going to dive too much more into these, but they're kind of the background info. CEC is more related to that texture, and organic matter is more related to that soil reservoir of nutrients. So soil pH, really this is the first part that we can actually maybe have a relatively outsized effect on what our soils are doing. But it's a measure of that soil's acidity or alkalinity. It's influenced by mainly the parent material. So most of our cropland here, I guess I shouldn't say that. Depending where you're at, we may have very different parent material, whether it's limestone or whether you're on more of the shield that we have a lot of acidity in different pockets, but also related to precipitation and erosion of that soil as well. It impacts a lot of different things: soil organism activities, nitrogen fixation by legumes, and nutrient availability especially. And so I've got a chart here that's showing kind of a representation of the different plant nutrients that are required for healthy growth. And kind of the wider the bar is, the more available that nutrient is at a given pH. And so we can see here that with a nutrient like phosphorus, for example, at a very low pH, 4.5, we've got very low availability of that nutrient. And when we get to that higher end, that 8.0, again, we're seeing it taper off. Something like manganese, we've got a very high availability at a low pH, but really tapers off when we start raising that pH. So really what it comes down to is for most crops, we've got a pretty good range of around 6 to 7.5 that fits well, keeps those nutrients available as much as possible for that plant to be able to grow and yield healthy. And it is something that is absolutely critical for crop growth. So the chart that I've got here is it's actually a study from about 90 years ago in Ohio. But what they did is within an acidic field, they limed certain areas to different pH levels, gave it some time, and then planted different crops in there to see just how critical that pH level is for each of those crops. And so you can see along the top end there, something like oats or wheat, they're actually pretty tolerant to low pH. They can get, 80, 90% of their relative yield, even at what we'd consider a very low pH level under 5.5, for example. On the other side, our legumes, alfalfa, sweet clover, and red clover, as well as our barley and timothy, some of our grasses. They don't perform well at a low pH, and it's not until we get closer to that neutral pH that we'd really be happy at all with that yield. And so it is something that is, depending on the crop that you're growing, can be very, very critical to growth, or, in some cases, it might be finding the right species to fit that pH that's in that soil. And so this is a chart that's pulled from our forage production guide, looking at the target pH of some of our different species that we may have. And again, similar to the last one, kind of shows that some types of plants have a much wider range of you know, growth, being able to grow in pH, whereas others are much more susceptible to yield loss at low pHs. And so when it comes down to our recommendations, we can break it down by targeting a pH of somewhere between 5.5 and 6.5 is kind of a minimum target pH. But really, it comes down to knowing where that lime is beneficial. And so, depending on the species that you've got in your pasture or in your forage crops, they may require a little bit higher pH, a little bit more lime requirement than some other crops. If we look at buffer pH, so soil pH is kind of whether that soil is acidic or not. Buffer pH is how resistant that soil is to change the pH. So having a lower buffer pH means it's more resistant to change, and really what it comes down to is more lime required to raise that pH to that target that we're looking for. So this is what really determines the lime requirement, and this is a chart pulled from our agronomy guide for field crops, looking at different target soil pHs and the lime rate that we'd need depending on that soil's buffer pH. So at a very low buffer pH, we'd need a lot more lime to get up to that target pH than we would. And this is something that, that buffer pH we can't really change. That's that soil's natural buffer to change. And so this is kind of how we determine the likelihood of being able to change that. So this is based on being able to incorporate that limestone. Obviously, with a perennial pasture, we're not able to incorporate. So the drawback is that it may take longer for that lime to work, but we can also split apply that lime, which may save a bit of cost, and also get that same job done just over a bit longer time span. And these recommendations are also something that needs to be based on lime quality. And I'll touch a little bit on that when it comes to choosing a liming material. So the number one factor is quality. We want to know how well does it neutralize that acidity. If it's a product that's not really going to work, there's not really any point in applying it. And so we determine this effectiveness by something called the agricultural index, which looks at the neutralizing value and the fineness rating of that lime. So the neutralizing value is really what kind of a compound is that. So we've got several different sources of liming material in the province, and depending where you're located, some may be more readily available than others. But essentially what this chart is showing is that compared to A calcitic lime, something like wood ash is, maybe half as effective. Something like wollastonite is maybe 60% as effective. And gypsum is 0% effective. So if you're using gypsum to try and lime, you will not change that pH whatsoever. So it's important to know what type of material you've got to be able to figure out how well we can expect that to neutralize that acidity. And if we look at the fineness rating, we want to know how fine it is because that really affects how quickly it dissolves and how quickly that lime can change that pH. So if we picture it, if you can picture a rock, if we're throwing a rock out into that field, there's only so much surface area on the outside of that rock that can actually react with the acidity in the soil. If we break it down to a fine, fine powder, all of a sudden there's much more surface area in that same volume. And the outside of every tiny bit of that powder, that surface area can now react. So having it finer ground means it can get to work quickly. It can get to work more effectively and really change that pH. And show the chart I show here is looking just at that. So 100 mesh, so a very fine screen. We can see that that pH changes rapidly, and we get a much higher pH change than we do with something like a 20 to 30 mesh, which is really ineffective when it comes to liming. And so that egg index, that's absolutely necessary to know. And you can get that from your lime suppliers if you require lime. But that's absolutely something that you need to know when it comes to comparing different types of limes, but also when it comes to really looking at that recommended amount. And so oftentimes we can use that to compare to see how much more one lime source may be worth than another to really determine what's best for our field. There are some other considerations when it comes to liming material, the nutrients that may be available. So dolomitic lime also has magnesium. If your soil test shows you're low in magnesium, things like K-lime also have potassium included as part of that. So be aware of the source and maybe there's some nutrients that might benefit your particular pasture. But also cost and transportation are a big consideration, especially if you're in an area that is, doesn't have that limestone source anywhere close. And so it's something that is obviously a critical factor. But what I want to touch on here is that not all lime is the same. And so if we look at two different sources here, we've identified through our soil test that we've got a lime requirement of 9 tons per hectare or 4 tons per acre on the field. Looking at the cost per ton, I think we can all agree that the $30 per ton of lime B looks like a much better deal. But again, once we look at the egg index of that, we can see that it's a much less effective lime, maybe a different source, a different grind, that it's not as fine, not able to work as quick. And so when we adjust the rate based on that agricultural index, it really changes the rate that we actually require and can really impact the cost on a per acre or per hectare basis of that lime that we need in total. And so it's absolutely important that we look and identify that the cheapest source is not always the best source when it comes to lime. And like I mentioned, that lime, it can be a pretty pricey input, but it doesn't all have to be in a single shot. And really, to me, lime is such an effective way of amending that soil's fertility that I would sooner spend $200 in lime than I would on phosphorus or potassium if that's what that soil required. It's going to do the job to make those nutrients that are there that much more available. And really, it's the number one way to amend that soil if that's what you need. If you're already in a high testing pH or kind of around that neutral zone, it makes no sense to apply that lime because you're not going to gain anything. But when you're in an acidic soil test, that's where you can absolutely gain some major benefits really quickly. Changing up to phosphorus and potassium. So if we look at our at our P and K. We're assuming now that we've kind of looked after our pH. We've made a plan to get it under wraps. What we're looking at here is our OMAFA recommendations for forages and hay. And we can see that we can break these into, roughly two or three different categories. So what we normally consider as low testing soils, we've got here as high response, outlined in the red, phosphorus on the left-hand side and potassium on the right. And what that shows is that those soils at that soil test levels are most likely to respond to added fertilizer. And when it comes to pasture, we've got some different numbers here than we might have for a crop of alfalfa, for example. But really, what we're looking at is how responsive is that crop likely to be to added fertility. And so we've got our highly responsive soils here. So showing under 10 part per million of phosphorus and under 80 to 100 part per million of potassium is really where we're going to see it's absolutely critical to have that fertility applied. Kind of our middle ground here, looking at 10 to 15 or 10 to 25 part per million, depending if you're seeding a new seeding of that pasture or forage for phosphorus, and anywhere from 80 to 150 part per million of potassium. That's where we're seeing kind of a moderate response. So in a lot of cases, this is maybe the zone that we should be targeting somewhere in this. That's where, if the fertilizer price is high and we don't need to apply, then we can cut back. And where we're maybe not going to see a response, but we're also not at the risk of overloading that soil, applying more than we need to, and wasting that input value. And then it comes down to what we consider high testing soils. So over 26 part per million of phosphorus and over 150 part per million of potassium. And this is where we're really likely to see not a great response to fertilizer most of the time. And so this is where, if you've got soils testing here, it really doesn't make sense to apply more fertility to those. But if we are looking to build those phosphorus and potassium levels, like I mentioned, the number one way to do that is through soil pH. So the chart I've got here shows the availability of phosphorus at different soil pH. And we can see that when it comes to phosphorus, most of that phosphorus is tied up by other minerals within that soil most of the time. And it's really only that pH somewhere between 5.5 to 7.5, but ideally between 6 and 7, that we can really get that maximum availability of phosphorus. So, it may be a little bit different thinking, but if you're looking to build phosphorus levels or potassium levels, you should be looking at your lime first. After that, that's where you can kind of make a plan when it comes to the fertilizers that contain phosphorus and potassium, whether you're looking to build those up, and really to build those basically requires applying more than that is being removed from that field. So depending on your stocking rate of a cow calf, for example, may take more or less fertilizer on a yearly basis to build those up. But as long as we're applying more than is being pulled out, it will build that soil. It may just take a long time to build those soils up if we're putting on a relatively low amount. Nitrogen and sulfur, very critical minerals, especially when it comes with nitrogen to our grass species. Build a lot of protein and really important to yielding. And it is very species dependent. So our legumes, they obviously don't require nitrogen. They, assuming there's enough of the nodulation occurring in the soil, they will pull the nitrogen from the atmosphere and don't require additional nitrogen. But if we've got mostly grasses within that field, then that's where nitrogen will be really effective in boosting that yield. Sulfur is kind of an interesting area, and it's one that we're seeing more and more of a response on a yearly basis. It's still not every field every year, but in a lot of cases, our grasses, alfalfa especially, any brassica species, they're very responsive to added sulfur fertilization. And so if we're in a spot where we are seeing response, the general recommendation is 5 pounds of sulfur per ton of that forage. So switching a little bit to some of the research that's gone on. So I kind of mentioned that global study first thing, looking at fertilization and how it needs to be site specific. This is one that's more Ontario specific. So this is a trial led by Dr. Kim Schneider from University of Guelph into some low testing soils at the Elora Research Station. They tested 19 different species and mixtures, anything from pure grasses to pure legumes to some of the typical hay and pasture mixes that are out, and looked at 3 different fertility treatments. So control, which is 0 fertilizer application. The second one is kind of a what I'd call misguided pasture standard that triple 19 or triple 15, depending on the retailer. It's kind of been the old standby of, well, we don't really know what you should apply to your pasture, so we'll give you 100 pounds of this, and it's a balanced mix, so it's probably not going to hurt us, but we're maybe not doing as well a job as we could be. And then the third treatment is taking soil tests and actually fertilizing those according to our OMAFA recommendations. And so what they found was we look at this is the total yield over the 3 years of production that was part of the study under the 3 different management treatments. So the black bars in each of these are the yield when we are following the OMAFA recommendations based on the soil test. The white bars are with no fertilization, and the gray bars are with the 100 pounds of triple 19 fertilizer. So breaking this apart, we've got our grass single species on the top, broken out by species. And then on the bottom half of the chart is grass and legume mixes. The interesting thing that is that in every single treatment, the OMAFA recommendations from that soil test out yielded the no fertilizer as well as the triple 19. So when it comes to the grass and legume mixes, a lot of times that's the potassium that may be missing out when it comes to that triple 19. Something like alfalfa takes a pile of potassium out of the soil, so being able to replace that is critically important. But also when it comes to some of the grasses, things like phosphorus and nitrogen, if we're under applying those and we're in a low testing soil, it may be absolutely where we're able to see some major response to that. And if we look at the net profit in each of those same situations, this is the cost of that fertilizer, the cost of application, and the yield that we're getting out of it. Does it pay to apply those? And looking at the bottom, every time we've got a grass legume mix, we can see that with very few exceptions, it statistically pays to fertilize that according to that soil test each and every time. When it comes to the grasses, it may be a bit more of a mixed bag within those 3 years. And in some cases, we can see that there's a statistical advantage. In other cases, there's maybe not so much of a difference. What I would say is that this is based on 3 years only. And so given a long-term outlook at the fertilization, if we were to use that fertilization, given enough time, those soil test levels would be built up a bit more, where we're more likely to have that higher baseline fertility. We're more likely to have that higher baseline yield, and so the profitability over those different species, given a longer time frame, I would expect to improve even more than they currently are here. But Long story short is that we can see if we're looking to improve that soil fertility within that pasture, that we can absolutely get more production out of that same area. And depending where and what you're growing, it may make more or less sense to put a lot of fertilizer on all at once to build those up quicker, or it may make a bit more sense to have that slower kind of a build process in mind when it comes to things like phosphorus and potassium. What I'm going to switch to here is a tool that you can use on your own farm or with a certified crop advisor, your agronomist, to help figure out uh, a game plan when it comes to crop fertility. The first tool is the crop nutrient tool within AgriSuite. And I'd invite you to Google AgriSuite, test it out. There's a lot of functionality here. But really what it is, you can put in your soil test value, the type of crop that you're planting, that you're growing, whether it's a pasture or field crop, and you can get some recommendations on what nutrients are required for that production, as well as the nutrients that will be removed, in this case from pasture cut for hay. And if we want to really look at that nutrient value, we can really get that from a lot of cases with manure. So the absolute most important thing is to get that tested. If we're going to apply that on our pastures to help build that fertility, we want to have it tested. We want to know what nutrient levels are there, and really we can try and figure out where best to use that. The next one is the organic amendment tool, and that's really where we can figure out from that manure test how we can best use that manure and maybe where it's best used. So again, we can plug in the crop that we're planting, some details about the type of manure, the test results that we've got, or pull from the data bank that exists within the program, and really look at the nutrients that we're getting out of that. We can also look at the economic value of that in case you've got manure that maybe you want to sell to a neighbor, or really look at the value of that. I see we're getting close to time here, so I'll speed through these last few slides, but some of the most important things are when it comes to fertilization, looking at using that 4R approach, using the right product, the right rate, the right time, and the right place. So if we look at the right time, anytime we're looking to apply lime, we want to get it on as soon as possible. If we're talking about nitrogen, we're wanting to get it on where we can reduce the losses and really looking at meeting that demand. So if we can split apply that, after grazing, giving it time to get into the plant before that next round of grazing is really ideal to get the best effective use of that nitrogen. When it comes to phosphorus and potassium, it often makes sense to apply in the late summer or fall, especially if we're low in those nutrients, because it gives it a bit more time to get into that pasture and maybe reduce the risk of things like grass tetany from high potassium and luxury consumption of that potassium. Can also look at using the right place. So if we've got that soil sample showing us that we've got an area of higher testing or lower testing soils, we may be able to focus on applying manure or fertilizer in one zone versus another. And we can do that variable rate application with the equipment that we've got. So precision application doesn't necessarily mean that we've got to have all the fancy equipment with all the tools on it. There's a lot of ways that we can make it work just with the equipment you've got on farm. When it comes to bale grazing, that's another thing that we can do to kind of help with that precision aspect. Relocate those nutrients from a high testing to low testing area just by using that placement of those bales. And so if we look at that bale grazing and kind of that wasted hay, so what's the value of that? We can look at the amount of nutrient that's included within a bale. We look at the amount that's wasted, and we can kind of come up with, depending on how many of those bales you've got on an acre basis, We can look at how much of that nutrient might actually be available just from, what's essentially a wasted hay being unfed within that small area. So again, improved pasture fertility can absolutely bring improved yield to that pasture and improved production, which can absolutely enhance that pasture you've got. And really, it's looking at that soil test, taking it, using it, and building that up with your lime first of all, if needed, as well as the phosphorus and potassium, using some of the tools like AgriSuite that we've got, and placing those nutrients to the best of our ability where they are most needed. And so with that, I think I'm out of time, but please, if you got any questions, feel free to get in touch with me.